Okay, so we're on page 12. This is C4, and we're going to do C4 in two parts. So this will be part one. And shortly, guys, you'll have to kind of replicate what I've done here on the paper. I use 3 different colors, but you don't even have to use colors at all if you don't want. And so we'll come back to this page in a moment and we'll write some stuff down. But I think it'll be faster if I explain how I drew these shapes just in a shorter way. Okay, so this you don't need to write, but please just pay attention. So, all right, so I have drawn 4 times here the same graph. Let's say it's the graph of f of x. And the integral from a to b of f of x is equal to the exact area, and it's the exact area under the curve on this interval. Okay, so here's our interval from a to b. Okay, and from a, I'll go up to the graph, and from b, I'll go up to the graph, and then I'll color like exactly the area. Okay. All right, so that would be the exact area, except this is not like a type of shape that we have the area for, like a formula for. So we're going to use, instead of getting the exact area, we're going to use rectangles and trapezoids to approximate the area. And there's going to be 4 different types of approximations. So a left endpoint approximation. So the way that a left endpoint rectangle goes is we're going to have the same base, so from A to B. And if you look at the base, there's 2 endpoints. There's A and B. A is the left endpoint. So for a left endpoint rectangle, you go to the left endpoint of the interval. From there, you go up to the graph. Okay, that should have looked vertical. You go up to the graph, and then this is the height. Okay, so that is the height of this rectangle. So now I'm just going to draw a top base, which is parallel to this one. So like this and like that. Okay, so that would be a left endpoint rectangle. Its area is not exactly this, but we could use it to approximate. And if we used more than one rectangle, then it would be even better. Now, a right endpoint rectangle, which we could also use to approximate this. So we've got the same base of the rectangle, but for the height, instead of going from the left endpoint, we go to the right endpoint, up to the graph, and then that's going to be the height of our rectangle. So now I just do like a horizontal line. Okay, so that's a right endpoint rectangle. And obviously these would give us 2 different areas, but they are both approximations for that area. Okay, a midpoint rectangle. So for a midpoint rectangle, you don't use the ends to go up to the graph from. Instead, you locate the midpoint, and from the midpoint, you go up to the graph from there. Okay, so this is going to be in the very middle of the top base, and then you just kind of, horizontal to the left, horizontal to the right. Okay, so that would be a midpoint rectangle. And then what gives the best approximation is trapezoids. So for a trapezoid, all right, so let me be clear about one thing. All right, for the rectangles, this is the base, this is the height. Okay, for each rectangle, that's the same. But for a trapezoid, I'll do this in a different color because it's different. For a trapezoid, this interval is actually the height. All right, that's the height of the trapezoid. And a trapezoid, guys, has 2 bases. So let me turn it to the side because we usually see trapezoids like this. So this is the height of the trapezoid. And then for the bases, you go up from the left endpoint up to the graph. And then you also go from the right endpoint up to the graph, and those are the bases. So height, base 1, base 2, and then you connect those, and then this would be the trapezoid. All right, and that's going to give the best approximation. And this is the height, and this is base 1, and this is base 2. All right, guys. So I'll post this in our document, but you don't have to write it down. Okay, so now back to this. Okay, so a trapezoid area. So you'll want to write this down. So the trapezoid area, and our trapezoids are going to be on their side. So the height is here, and then the bases are like that. And the area is base 1 plus base 2 over 2 times h. And I just want to be clear about one thing here, guys. This is the average of the bases. So another way of looking at it is the area is the average of the two bases times the height. Okay. All right, so here it goes. So use the indicated sum to approximate the integral from a to b of f of x. And actually, guys, we're going to change this integral from 0 to 8 because that's our interval each time. Okay, so I have the same graph every time. It's actually this graph. And what I've colored in yellow is the exact area. Okay, so what's in yellow is this integral exactly. But we're going to use rectangles and trapezoids to approximate. So rectangle sums are called Riemann sums. So Riemann, rectangle, they both start with R. So when you hear Riemann, think rectangle. So this was left Riemann sum with 3 subintervals. Okay, so this was my first rectangle. This is the base. For the height, I went to the left endpoint and up to the graph. Okay, so the base is 1, the height is 2, this area is 2. Okay, next rectangle. This is the base, left, up to the graph, finish it off. Base is 4, height is 7. So 28. And guys, if it's hard to see the height from the graph, I use tables down here. These values are the same values in the graph. So if you're not sure, just refer to those. All right, finally, this one. This is the base. I went to the left endpoint to get the height. And this is 3 times, I think that's 9. Let's see, 5, 9. Yes, 3 times 9, that is 27. So I just add those together. 2 plus 28 plus 27 is 57. So 57 is an approximation for this yellow area. All right, now we're going to approximate the same area using right Riemann sums. Okay, with 3 subintervals. And I indicated the subintervals on the picture. Okay, so 0 to 1, except this time I'm getting a higher height because I'm using the right endpoint. Okay, the next rectangle, I'm using the right endpoint to get the height. Third, same, I'm using the right endpoint this time. So the base is 1, the height is 7, area is 7. Base is 4, height is 9, area is 36. Base is 3, height is 5, so the area is 15. Okay, I got 68 for that. I hope that's right. Okay, so earlier I got 68. 30, 40. Let me double check. 7 plus 36 plus 50. 58. Whoopsie. Okay, glad I checked. All right, so that is again an approximation for that yellow area, but it's different. Different approximation. Middle Riemann sum. So this time, so this was the base, then I went from the middle up to the graph and completed my rectangle. Same here. Base, middle, up to the graph, height, etc. Okay, so this first one, base is 1 and the height is 7. And it's hard to tell on the graph, but I'm looking down here to see. So the base is 1, the height, are we sure? No, sorry. I'm going to a half. So I should be looking here. All right, so the height would be 6. So 1 times 6 is 6. Next, 4 times 7.5 is 30. Okay, and then 3 times 8 is 24. I think that's 66. 60. Okay, yet another approximation for this area. All right, finally, trapezoids. Okay, so for trapezoids, guys, we're going to have to use this formula here. Okay, so for this first trapezoid, we'll do the bases first because we got to average them. So base 1 is 2, base 2 is 7. So that's going to be 2 plus 7 divided by 2, and then the height is 1. Okay. All right, so that's 4.5. All right, so this first trapezoid's area is 4.5. All right, this next one. Base 1 is 7. Base 2 is 9. So 7 plus 9 divided by 2, and then the height is 4. So this is 32, I believe. Yes, okay. And then this last one, base 1 is 9 plus base 2 is 5 divided by 2, and then the height is 3. So that's 21. 57.5. Okay, that is yet another estimate for that. Okay, now guys, we're about to find the same exact sums, except just from a table. And this is really helpful because in the past I've had students, if they had a table and they were doing some kind of a estimate for an integral, I've had them plot the points, draw a picture, etc. That takes a long time. So try to, follow along with me to see these patterns. This will go fast. Okay. So a left Riemann sum with 3 subintervals. Okay. So the difference, so let's look at these x's. So I got 1, 2, 3. Okay, so there's 3 subintervals for the x's. So from 0 to 1, that's going to be base 1. From 1 to 5, that'll be base 2. From 5 to 8, that'll be base 3. Now for the heights. Guys, if it's a left Riemann sum, so there's 3 rectangles, so we're only going to use 3 heights. And there's 4 y values. So since it's a left Riemann sum, our first height is going to be the leftmost endpoint. So I'll put h1 for height 1. And then our next height will be the next one. All right, so we're leaving off the very right one. Okay. All right, so here we go. So base 1 is 1, and then height 1 is 2. So that's 1 times 2. Plus, the next base is 4, and then the height is 7. Plus, the next base is 3, and the height is 9. All right, and you add all of those up, and you will get 57 just like up here. Okay, next. So right Riemann sum with 3 subintervals. The bases are going to be the same. All right, so base 1, base 2, base 3. But this time, right Riemann sum. So we're not going to use the leftmost endpoint. Our first height is going to be the right, the height on the right. So that'll be height 1, height 2, height 3. Okay, so base 1 is 1 times the height, which is 7, plus 4 times 9 plus 3 times 5. Add all those up. That's 58. Okay, beautiful, which is the same thing we got here. All right, now a middle Riemann sum. if they're asking you to do a middle Riemann sum on a table, they're going to have to give you, more than this because you're going to need the midpoint of each interval. So so from 0 to 1 is our base 1. From 1 to 5 is base 2, and from 5 to 8 is base 3. Then for the heights, we're using the middle. All right, so this is height 1, height 2, height 3. Okay. Alrighty, so base 1 is 1 times height 1 is 6 plus base 2 is 4 times height 2 is 7.5 plus base 3 is 3 and then 8 and that's 60. Okay, same as what we got there. Finally, trapezoidal sum with 3 subintervals. So this is going to go a little bit differently, guys. With trapezoids, these used to be the bases, but these are now the heights actually, okay? So this is going to be height 1, this is going to be height 2, and that's going to be height 3. And what do you do? What are you multiplying these heights by? You're multiplying the heights by the average of the bases, okay? So down below here, let's average these. Okay, so I'm gonna go like this, and then we'll get their averages. And then maybe we should write for our notes, average of bases. Okay. 2 plus 7 is 9, divided by 2 is 4.5. Okay, so 4.5 is the average of those bases. 7 and 9 is 16, divided by 2 is 8. Okay, so 8's the average there. 9 and 5, 14, divided by 2 is 7. Okay, so that's the average of the bases. So it's going to go like this. So it's going to go 4.5, that's the average of the bases, times the height, which is 1, plus average of the bases, 8. Height is 4, plus 7 times 3, and we get 57.5. Okay, guys, so that's how you do these sums. And, okay, I will talk to you later.